In this video, we're going to be rapid firing through the first 10 problems on the 2023 AMC 10A that took place yesterday on November 8th, 2023. So let's get started. Problem number 1. Cities A and B are 45 miles apart. Alicia lives in A and Beth lives in B. Alicia bikes towards B at 18 miles an hour. Leaving at the same time, Beth bikes towards A at 12 miles an hour. How many miles from city A will they be when they meet? So we have this thing here, and that is 45 miles. And Alicia travels at 18 miles an hour. Beth travels at 12 miles an hour. And that means that they move relative to each other at 30 miles an hour. And if they meet in x hours, then 30x must equal 45, so x is 1.5 hours. And after 1.5 hours, since Alicia is traveling away from A, that means that the answer will be 18 times 1.5, which is 27, which is answer E. Problem number 2. The weight of 1/3 of a large pizza together with 3/2 cup of orange slices is the same as the weight of 3/4 of a large pizza together with 1/2 cup of orange slices. A cup of orange slices weighs 1/4 of a pound. What is the weight in pounds of a large pizza? So if L is large pizza, and C is orange, a cup of orange slices, then that means that 1/3 L plus 7/2 C is equal to 3/4 L plus 1/2 C. Rearranging, we get 3C is equal to 5/12 L, so L is equal to 36/5 times C, which is 36/5 times 1/4 from what we're given, which is 1 4/5. And that gives answer A. Problem number 3. How many positive perfect squares less than 2023 are divisible by 5? So 45 squared is 2023, but 40 squared is only 16. That's 2025, sorry. And that's 1600. So that means that the perfect squares are 5 squared, 10 squared, all the way to 40 squared. And since 40 is 5 times 8, our answer is 8. So A. Problem number 4. A quadrilateral has all integer side lengths, a perimeter of 26, and one side of length 4. What is the greatest possible length of one side of the quadrilateral? So we can let the longest side of the quadrilateral be A, suppose. Then we have something like this, or something like that. So we have 4, and then these are the other lengths. So let's go ahead and go down from the answer choices. Is A equal 13 possible? So we have 13, and the sum of these three other sides is then 26 minus 13 is 13. But that would mean that the quadrilateral is just a line, so that won't work. Answer is not E. So what if it's equal to 12? Well, we can easily construct an example, 4, 4, and 6. And such a quadrilateral exists. So our answer is D, 12. Problem number 5. How many digits are in the base 10 representation of 8 to the 5 times 5 to the 10 times 15 to the 5? So that's 2 to the 15 times 5 to the 10 times 3 to the 5 times 5 to the 5. And that ends up being 2 to the 15 times 5 to the 15 times 3 to the 15, which is 10 to the 15 times 3 to the 5, which is 243 plus 15 zeros. So our answer is 3 plus 15 is equal to 18. And that's answer E. Problem number 6. An integer is assigned to each vertex of a cube. The value of an edge is defined to be the sum of the vertices of the two vertices it touches, and the value of a face is defined to be the sum of the values of the 4 edges surrounding it. The value of a cube is defined as the sum of the values of its 6 faces. Suppose the sum of the integers assigned to the vertices is 21. What is the value of the cube? So let's go ahead and try finding out what the value of a face is. So this is A, B, C, and D. And that's A plus B plus C plus D, and D plus A. And when we sum all of them, the value of a face ends up being 2 times the sum of the numbers on it. And so the sum of two opposite faces ends up being the sum of the values of two opposite faces ends up being 2 times the sum of the total cube. So that's 2s. And if we multiply that by 3 for every single pair of opposite faces, the value of the cube is 6 times the sum of the numbers of all the vertices. And s is equal to 21, so that's 6 times 21, which is 126. Answer D. Problem number 7. Janet rolls a standard 6-sided die 4 times and keeps a running total of the numbers she rolls. What is the probability that at some point her running total will equal 3? So there are 3 cases that can happen. So one is that she rolls 3 first try, and that has probability 1/6 happening. 2 is that 3 and 2 tries. And out of the 36 possible outcomes, 36 is 6 squared, only 2 will give a sum of 3. 2 and 1, and 1 and 2. So that is 2 over 36. 3 is when it takes 3 tries. Then that will mean that it would have to be 1, 1, and 1 out of the 216, which is 6 cubed possible options. So that's 1 over 216. And because we have this 216 here, let's express everything with a common denominator. This is 36 over 216. This is 12 over 216. And that's 1 over 216. So the answer is 36 plus 12 plus 1, which is 49 over 216. Answer B. Problem number 8. Barb the baker has developed a new temperature scale for a bakery called the breaded scale, which is a linear function of the Fahrenheit scale. Bread rises at 110 degrees Fahrenheit, which is 0 degrees on the bread scale. Bread is baked at 350 degrees Fahrenheit, which is 100 degrees on the breaded scale. Bread is done when its initial temperature is 200 degrees Fahrenheit. What is this on the breaded scale? So we have 110 and 350, and then 200 is somewhere on here. So that's 0 and 100. So the distance between these two is 90. The distance is 150. So 200 is 3/8 of the way from 110 to 350. And similarly, the corresponding breaded temperature scale, since it's linear, is 3/8 of the way from 0 to 100. So the answer is 3/8 times 100, which ends up being 37.5. Answer D. Problem number 9. A digital display shows the current date as an 8-digit integer consisting of a 4-digit year, followed by a 2-digit month, followed by a 2-digit date within the month. For example, Arbor Day, which is on April 28th, 2023, is displayed as over here. For how many dates in 2023 does each digit appear an even number of times? So we have 2023 something, 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 something. So there are 2 cases as to what this thing could be. First, there's a case where it's just a 0. Then we need to have the number 3 here, and then some other numbers. So the first case is that it comes here. Then these 2 digits must be equal, so that's 311, and then 322. And then the second case is that ends up being the second digit out of the 3, in which case we can say 131. And 232 doesn't exist because there are only 31 digits in a month at most. So then the third case ends up being when it's last. Then there's 113 and then 223. And then the second case is 2023 1 something something something. Then 1, 0, and 3 appear an odd number of times so far. So that would mean that we have to have the numbers 0, 3, and 1. So that's 2023 1, then 0, 3, and 1. There are 3 cases. One is that the 1 comes first, then we have 1130, then 1103. Then 2023, if the 1 comes second, that becomes 1013, and 13, and there's no month starting 13. So that means that next option is 1031, Halloween 2023. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is our answer. Problem number 10. Maureen is keeping track of the mean of her quiz scores this semester. If Maureen scores an 11 on the next quiz, her mean will increase by 11. If she scores an 11 on the next 3 quizzes, her mean will increase by 2. What is the mean of her scores currently? Suppose that her scores have some s currently, so s plus 33 over n plus 3, suppose she did n quizzes so far, minus s plus 11 over n plus 1 is equal to 1, because it only increased by 1. And we can go from there. Then if we express everything with a common denominator, it ends up becoming 22n minus 2s over n squared plus 4n plus 3 is equal to 1. So 22n minus 2s is equal to n squared plus 4n plus 3. So s is equal to negative 3 plus 18n minus n squared over 2. And that means that the average currently, s over n, is equal to negative 3 over 2n plus 9 minus n over 2. And if we plug in n equals 3 or n equals 1 on that matter, this ends up becoming 7. So we might think that the answer is 7. And indeed, if n equals 3, then that means that we have 7, 7, 7, 11, 11, and 11 ends up doing the trick. So our answer is 7, which is answer D. So thank you so much for watching this rapid fire through the first 10 problems on the AMC 10A that took place yesterday.